Start with the name of Allah, who is kind and merciful. तो आज हम स्टार्ट करेंगे पढ़ेंगे स्टैंडिंग वेव्स. Standing waves are, these are also called stationary waves. Stationary waves. अच्छा, स्टैंडिंग वेव्स हम किसको कहते हैं? स्टैंडिंग वेव्स हम कहते हैं those waves which cannot propagate energy away from the source. These are called standing waves. Waves which cannot propagate energy away from the source are called standing waves. But we know that the basic characteristics of wave is they propagate energy. Propagate energy, and every wave propagates energy. But standing waves are those waves which pile up between the two fixed points. It means that these remain between the two fixed points, so that's why they will not propagate energy away from the source. Okay, standing waves are the mechanical waves. These are mechanical waves. मैकेनिकल वेव्स हैं. और अगर स्टैंडिंग वेव्स एनर्जी प्रोपेगेट नहीं करती तो कैसे बनी होती हैं? क्या ये एक सिंगल ट्रैवलिंग वेव तो नहीं होगी यकीनन, क्योंकि स्टैंडिंग वेव है. तो स्टैंडिंग वेव जो है that is process of superposition. These are formed due to the process of superposition. So standing waves are the result of superposition principle. What is superposition principle? Interference of two waves, that is called superposition principle. When two waves superimpose to each other and effect on each other, that process is known as superposition. Acha, then under what conditions the superposition occurs in standing waves, and what should be the properties of waves to occur the superposition principle? So there are many methods, many different methods to produce the superposition between the waves, among the waves, but there in standing waves, the superposition, for the superposition principle, the waves having properties, let's say two waves having same frequency, amplitude, but opposite in direction. Opposite in direction results the standing wave. जब इन दोनों वेव्स में सुपरपोजिशन होगा तो एक स्टैंडिंग वेव जनरेट होगी. इट मीन्स दैट स्टैंडिंग वेव जनरेट होगी फ्रॉम द ट्रैवलिंग वेव्स. इट इज़ generated or produced from traveling waves, बट ट्रैवलिंग वेव्स की जो प्रॉपर्टीज़ हैं वो क्या होनी चाहिए, सेम फ्रीक्वेंसी हो, एम्पलीट्यूड हो, बट ट्रैवल इन अपोजिट डायरेक्शन, लाजमी जो है वो ये कंडीशन होगी। क्या इन्हीं कंडीशंस के अंडर सुपरपोजिशन प्रिंसिपल हो सकता है या कोई और कंडीशंस भी हो सकती हैं फॉर दी सुपरपोजिशन प्रिंसिपल? सो देयर आर आल्सो डिफरेंट कंडीशंस टू अकर दी सुपरपोजिशन फिनोमेना। ओके, जैसे कि beats are also result of superposition and other superposition occurs due to the phase difference, but there is superposition due to the opposite in direction and same frequency and amplitude. Okay, so let's consider there is a string and it is fixed at both the ends. If it is slightly jerked, the wave is generated into it, and the wave which is generated at the both ends, there is obstacle and the wave cannot pass through it, so it have to reflect. As it reflects, its phase reversal occurs. Phase reversal means कि ये इसका जो है वो लोअर पार्ट हिट कर रहा है, तो आफ्टर रिफ्लेक्शन where the lower part will be converted into upper part, but this process is reflection, and reflection occurs when a wave travels from rare to denser medium, strikes to the denser medium. Also phase reversal occurs, so this is the phase reversal. Phase reversal occurs. Phase reversal, when it occurs when a wave enters or enters from rare to denser medium. Okay, so when enters from rare to denser medium, a phase reversal occurs. So there is also a phase reversal. And what is phase reversal? How much it is? It is of pi, or we say 180, and the path difference will be lambda by 2. So there will be the path difference lambda by 2 and the phase reversal occurs of 180. अच्छा, पाथ डिफरेंस कैसे? जैसे देखें ये लोअर पार्ट है, ये अपर पार्ट, तो अपर और लोअर पार्ट के बीच जो डिफरेंस होता है पाथ डिफरेंस, दैट इज़ ऑलवेज लैम्डा बाय 2, बट कंसेक्यूटिव की बात कर रहा हूँ कि लेट सपोज अगर हम हमारे पास ये एक वेव है, तो ये अपर पार्ट और दिस इज़ अ लोअर पार्ट. लेट्स से कि ये कंप्लीट वेव हुई. अगर दिस इज़ अ कंप्लीट वेव, तो इनके बीच जो मतलब ये कंप्लीट वेव है अगर, तो दिस विल बी द वेवलेंथ. This will be complete wavelength lambda, but if we separate our part from it, then this will be half of lambda. So this will be half of lambda, and other one end also half of lambda. Okay, if we make partition it, lambda by 2, lambda by 4, lambda by 4, also this will be lambda by 4, lambda by 4. See, from this point to this point is lambda by 4. Again, from this point to this point is also lambda by 4. तो इस क्रेस्ट और इस ट्रफ के बीच जो पाथ डिफरेंस होगा, that will be lambda by 2, and the phase difference will be 180. अच्छा, phase difference कैसे? As we know that a relationship between phase difference and path difference is can be given by, this is phase difference and this is 2 pi over lambda into x. This is the relationship between path difference and phase difference. Okay, so if there is path difference of lambda by 2, then we have to calculate the phase difference between these two. Then for that this is a phase difference 2 pi over lambda into x. What is x? What is the path difference? Path difference is lambda by 2. So this lambda has been cancelled, then phase difference will be 2 pi over 2 and 2 again cancelled, so phase difference will be pi. So when a wave hits from rare to denser medium, its phase reversal occurs. Always its phase reversal occurs, phase becomes opposite at an angle of 180 degree, and whenever the phase reversal occurs, the path difference produces, that is by lambda by 2. So this is the relationship between path difference and phase difference. ठीक है, ये path difference और phase difference के बीच जो है वो relation हो गया. This is a phase and x is the path difference. ठीक है. Okay, so let के this wave is going to incident and this wave is reflected wave. If we express this is reflected wave and this is incident wave, we can say incident wave. ठीक है, यहाँ पे इस पॉइंट पे जाके हिट करेगी तो दिस विल बी इंसिडेंट एंड दिस इज रिफ्लेक्टेड, एंड रिफ्लेक्टेड वेव इज आउट ऑफ फेज विद रेस्पेक्ट टू इंसिडेंट वेव बिकॉज ऑफ एंगल इज 180 degree. Okay, so after the reflection, the reflected wave making superposition with the incident wave, and at one point these are supporting to each other and other point these are destructing each other. So the points where these two waves support to each other, constructive interference will be formed, and that point amplitude of a resultant wave will be larger, and the points where they will destruct to each other, the amplitude at that points will be minimum or 0. So these are the constructive points, and these points are considered as the points of destructive points. So there will be a minimum or 0 amplitude. What will be the resultant where these two waves construct each other and where the two waves destruct each other? If we want to calculate then we will go to the mathematical formulations. For that, we know that these waves are sinusoidal waves. Then if a incident wave, let's say if an incident wave having amplitude y1 is the amplitude of incident wave, and it is a node sine kx plus omega into t because of it is moving towards the right. Let's say this is equation 1. This is the amplitude of incident wave, this wave which hits to this barrier. Okay, one more point के these two waves constantly जो will reflect and once again these will pile up under these between these 2 points, so that's why energy will cannot be transferred away from the source. So that's why these are known as standing waves. Okay. Other wave which is reflected, the reflected wave moves opposite direction to that of the incident wave. Then the amplitude of that wave we can write as y2, we can write as y2 is equal to a node sine kx minus omega into t. Minus sign is applied because of they travel in opposite direction to each other. A node is same because of we have already mentioned that k having same frequency and same amplitude as clear from the figure. Okay. So when these two waves interfere and superposition principle occurs, then we apply the superposition principle, and according to the superposition we will find the resultant amplitude of the standing wave. So according to superposition principle, if we want to calculate the total resultant of amplitude of a resultant wave, we have to add these two amplitudes. Then because of superposition principle, so y1 plus y2 will be equal to y, and y is the amplitude of resultant wave. Then if we add y1, what is y1? y1 is equals to a node sine kx plus omega into t, and plus y2 is equal to a node sine kx minus omega into t. Okay, so y equals to this much. If we take common a node, if we take common a node is taken common, then remaining equation will be sine kx plus omega into t plus sine kx minus omega into t. So this is the resultant. Okay. Kx, once again, kx is the angle, but what is k? K here is kx is total angle, but we if we define the only k, that is a wave number. Okay, so y is equal to, if a node is same, then this is about the identity, and identity, this, let's suppose this is alpha, this is, we consider alpha, this is sine alpha plus, and this is sine, and consider this is beta. So that is the trigonometric identity, and according to that, sine alpha plus sine beta is equal to twice of sine alpha plus beta over 2 into cos alpha minus beta over 2. So if we apply the identity on this, that we will get sine, let's say sine alpha, at the place of sine alpha we have to put the sine kx plus omega into t. So this will be kx plus omega into t, and plus sine beta, sine at the place of beta we will put or use kx minus omega into t, and this will be equals to 2 twice of sine. At the place of alpha we have to place kx plus में omega into t, kx plus omega into t. In between them there is a plus sign, plus sign is applied, and beta. At the place of beta, kx minus omega into t is placed and whole divided by 2. And after that, cos and alpha. Again, alpha equals to kx plus omega into t, okay, and minus beta equals to kx minus omega into t and whole divided by 2, okay, kx minus omega into t whole divided by 2. So this will be get 2 sine kx plus omega into t. If we multiply this plus sign to this, that plus into plus kx plus minus omega into t over whole divided by 2 into cos equals to cos into kx plus omega into t, same, minus kx minus plus omega into t over 2. Again 2 sine same, this is 2 sine same, kx plus kx, this will be equal to 2kx, and this is plus omega into t, this is minus omega into t, so these will be cancelled, and kx plus kx will be equal to 2kx over 2 into cos kx minus kx, here they will be cancelled, and remaining one omega into t plus omega into t will be equals to 2 omega into t over 2. Okay. Then 2 will be divided to each other, then they also will be cancelled, and here they will also be cancelled. Then resultant we get that 2 sine kx, okay, and there is cos omega into t, but the cos omega into t refers the phase, so this is the phase, or we can say कि if we use this whole this is equals to this whole one twice of sine इसके, तो this is whole much equals to sin kx plus omega into t plus sin kx minus omega into t. Let's say this is equation number 1. If we put the value of this whole, the equation will become y is equal to a node, and at the place of this thing we have to put this 2 इससे मल्टीप्लाई हो जाएगा, तो दिस विल बी 2a नॉट साइन kx and cos omega into t, but cos omega into t is a phase, so we have to cancel it. Then remaining the amplitude of the wave we have to which is obtained 2a node sin kx. This is the resultant amplitude of standing wave. According to this equation, the resultant amplitude of standing wave maximum can be maximum amplitude will be, let's say, V maximum equals to, from this equation we can use 2a naught, but it can be plus minus 1, but when this amplitude will be equals to plus minus 2a naught, for that it depends upon the sin kx. So when sin kx equals to plus minus 1, then the amplitude of standing wave will be this much 2a naught. Okay, so what are the conditions at which we will obtain the maximum amplitude, and that must be equals to 2a naught. So let us discuss conditions for the maximum amplitude. And maximum amplitude का this is the resultant amplitude, and the condition for that is sin kx plus minus 1. If we have to obtain at some place, at anywhere, minimum amplitude, that will be equals to 0, and that for that condition sin kx also should be equals to 0. Let's discuss first we discuss the conditions for constructive interference, and where the maximum amplitude occurs, at that points we say constructive interference occurs, because of standing waves are the result of interference phenomena. If y equals to 0, then sin kx will be equals to also 0, and for that destructive interference will occur. Destructive interference will occur. Okay, then let's see when the constructive interference will occur. Conditions for constructive interference. Conditions for constructive interference. ओके जी, तो कंडीशंस फॉर कंस्ट्रक्टिव इंटरफेरेंस हमने कहा कि वी हैव डिफाइंड दैट वी वाई एम्पलीट्यूड शुड बी मैक्सिमम, एंड दिस will be equals to plus minus 2a naught, and this will achieve when sin kx will be equal to plus minus 1. If sin kx is equal to plus minus 1, then what should be the kx? What will be the kx where sin kx will be equals to 1? Its meaning is that at what angle do the sine have maximum value? Because of sine has maximum value of 1. So at what angles must be taken as the sine have value of 1? Let's say if we take the angle pi by 2, it means that 90. So it will be the sine equals to sine kx will be equal to plus 1. Or if we take, let's say if we take 3 pi by 2, it means 270 degree. At that point sine kx will be minus 1. Similarly, if we are taking, let's suppose 5 pi by 2, 7 pi over 2 up to n pi over 2. Okay, n pi over 2, or we can put it at the place of n 2n plus 1, 2n plus 1 pi by 2. So 2n, 2, if we place it 1, then 2 into n will be equal to leave this. But if we have the value of kx, if angle kx equals to pi by 2, 3 pi by 2, or 5 pi by 2, 7 pi by 2, or n pi by 2, we will get the maximum value of sin kx, and at these values we will get the maximum amplitude. Okay, what will be the positions? Positions of where we get the constructive interference are this much amplitude? If we want to describe it, let's say this is a wave. Let's say this is a wave and we want to locate the positions of maximum amplitude. For that we have to take the, let's consider this is a one complete wave. This is the one complete wave and this is an other complete wave. We will only take the two waves. Okay, so this is two waves from this point to this point. This is a one complete wave. From this point to this point is an other complete wave. If this is a complete wave, then how much its wavelength will be? This is one complete lambda, and how much this will be? This will be half of this. Then this is lambda by 2. Okay, this will also be lambda by 2. Similarly, this will be lambda by 2 and this will also be lambda by 2. But we get, and this is x is equal to 0. If we are taking the horizontal displacement for the positions of maximum amplitude, then this is origin, let's say, and this is lambda. Okay, this is lambda by 2. This is lambda by 2. Okay, if this is lambda by 2, then if we cut into two parts to lambda by 2, what will be the distance? Distance will be lambda by 4. So this will be the lambda by 4, and we see that this is a point where amplitude is maximum. Then we can say if x is equal to lambda by 4, then we get maximum amplitude, and maximum amplitude will be lambda by 4. If this point to this point is lambda by 4 distance, then from this point to this point will also be another lambda by 4. To this lambda by 4, this lambda by 4, this will equals to 2 lambda by 4, and similarly from this to this will also be lambda by 4. So if we count how many lambda by 4 are counted up to point this, so from this point to this point 1 lambda by 4, from this point to this point lambda by 4, and other lambda by 4, and from this to another lambda by 4, then this is the position where amplitude is maximum. Amplitude is maximum, but in downward direction from the origin. So this will be 3 lambda by 4, and if we see further, this is 3 lambda by 4, then we add into this will be 4 lambda by 4, and up to this will be 5 lambda by 4. So this will be 5 lambda by 4, 6 lambda by 4, and 7 lambda by 4. So this will be 7 lambda by 4 up to n lambda by 4. So these will be the positions of where we get maximum amplitude. Okay, so this x shows the position. X shows the position and kx shows the angle. Kx shows the angle. You may think that how kx shows the angle. As we know that k is the wave number. What is k? K is a wave number. Let us write here kx is the wave number. Sorry, only k, not kx. K is the wave number and k equals to 2 pi over unit length or lambda. So this is 2 pi over lambda. If we multiply both sides kx, then we will get 2 pi over lambda into x. If x is equals to lambda, if x is equals to lambda, because of x is a displacement, and in the terms of waves we have to describe the displacement in terms of wavelength. So kx will be equal to 2 pi over lambda into, at the place of x we have put the lambda. So by cancelling this, kx equals to 2 pi, and we know that 2 pi is the angle, and how much angle, that is equals to 360. So kx is the angle where x is the position. Okay, in a wave we have to describe the constructive interference, and we have already described whenever sin kx plus minus equals to 1, then maximum amplitude of plus minus 2 naught will be achieved, and this is achieved only whenever angle must be these, and at what positions we will get the these points or these constructive points where the amplitude is maximum. These will be these positions. Okay, and remaining one where the destructive interference occurs, where the amplitude we will receive the minimum amplitude. For that, let us describe the conditions for the minimum amplitude. Okay, conditions for minimum amplitude. इससे पहले अच्छा जो पॉइंट्स हमें ये जो मिली where the constructive interference occurs, ये पॉइंट्स वो हैं जहाँ पे मैक्सिमम एम्पलीट्यूड मिलेगा, and the points where we get the maximum amplitude, these points are known as antinodes. So these are the antinodes. These are antinodes. All these points, these points are sorry, not this, and this and this. These points are the antinodes. What are antinodes? How can we define antinodes? Antinodes are the positions where two waves cannot cancel each other, but can support each other. If two waves support each other, then that is called antinodes. Or we can define in terms of energy also, the points in a wave where potential energy is maximum, that is called antinode. Okay, now the conditions for minimum amplitude. So what are the conditions for the minimum amplitude? And the minimum amplitude will be equals to 0, and we see that k amplitude is the function of sin kx. Whenever sin kx changes, then amplitude also changes. So for this, if y is equal to 0, then sin kx must also equals to 0. Then at what angles the value of sin will become 0? Then if we define kx, let's say equals to 0 degree, then sin 0 degree is also equals to 1. Other one, pi is a 180, and at 180 degree sin theta will be equals to 0, and at 2 pi also sin equals to 0, 3 pi equals to 0, up to n pi, where n is a number and it is 1, 2, 3 up to so on. At this, n is a number, but n is only and only the odd number. Here n is odd number, n equals to 1, 3, 5, 7 up to so on. Similarly, at the positions is also the odd number, but at the positions of node the n is odd and also even. Okay, so these are the angles at which conditions minimum amplitude is obtained. It means that these are the destructive points. Minimum amplitude means there should be destructive interference. These are the destructive points, because of at these points amplitude of wave will become minimum or 0. There is suitable to say the 0. Okay, then what will be the if we want to define in terms of displacement, then in terms of distance, then how can we define? Let us again consider a wave. This is a wave. Consider this is a wave and this is origin, and at the origin point displacement is 0. So if displacement is 0, then this at this point the amplitude is 0 also. So first point जो हमें मिलेगी that will be at origin. At the origin displacement is 0 and amplitude of a wave is also equals to 0. If this is 0, this is lambda by 4, this much is lambda by 4 also. Then from this to this point this will be lambda by 2. Then at another node which is obtained at the distance of lambda by 2, but from the origin, if we take the distance from the first antinode, then this will be from this to this lambda by 2, half of this much, half of this, because of this whole is lambda by 2, then half will be lambda by 4, and other one is obtained at this, and this is how much? This is lambda, and other one is this will be 3 lambda over 2, this is 2 lambda up to n lambda. Okay, so these are the positions, these are the points at which nodes are formed or we obtain the minimum amplitude. Okay, so these are the points where minimum amplitude is obtained because of the destructive interference. Okay, the points where the destructive interference is occurred, these points are called the nodes. We call it nodes. And what is node? The node are the points where destructive interference occurs or where two waves intersect to each other. The nodes are the points where two waves intersect to each other, or in terms of energy we can say that the points where kinetic energy is maximum, that is called nodes. Okay, then what is the distance between consecutive nodes and the consecutive antinodes? If we take this is a node and this is another node, this is distance is how much? Lambda by 2, and from this one to this one this is also lambda by 2, and from one antinode to another antinode, or we say this is antinode 1, this is another antinode, this is how much distance? Lambda by 2. So distance between consecutive nodes and are consecutive antinodes is lambda by 2. Distance between consecutive nodes or antinodes is lambda by 2. Okay, from this point to this point is lambda by 2 but consecutive, and from this point to this point is also lambda by 2. From this point to this point is also a lambda by 2. Let's see. This is a wave. This is a wave. This is a one complete wave. From this point to this point is a wavelength 1 lambda. Okay, this will be the half lambda. This will be half lambda. Okay, this much to this much is lambda. Let's say this is lambda. From this much to this much is lambda by 2, and from this much to this much is also a lambda by 2. This is node, this is another node, this is node also, this is also an other node. So from node to node is lambda by 2, and this node to this node is lambda by 2. But if we want to take from this will be this this is lambda by, this is complete lambda, but from this lambda by 4 is cancelled, and again from this lambda by 4 is cancelled. So lambda by 4 plus lambda by 4 cancel from the lambda. So lambda by 4 plus lambda by 4, this will we get lambda by 2. This is complete lambda. If we subtract the lambda by 2 from the lambda, we will get lambda by 2. From this to this much, this to this much is also obtain the distance which is equal to lambda by 2. Okay, this is lambda by 2. So distance between two consecutive nodes are consecutive antinodes. Let us say this is this to this is lambda by 2. Okay, and from this much to this much is lambda by 2. This is lambda by 2. Okay, and from this much to this much is also a lambda by 2. If we want to take the distance between node and antinode but consecutive, node and antinode, we know that this is whole lambda and this is lambda by 2. So this to this is lambda by 2 distance. If we want to intersect at this point, this will be lambda by 4, and also from this to this is lambda by 4. This is antinode, this is node. So from the node to consecutive antinodes, distance is lambda by 4, and from this antinode to this node there is also another separation, that is lambda by 4. This is node, this is antinode, there is also a separation of lambda by 4, and from this to this is also lambda by 4. So distance between consecutive node and antinode, node to antinode or node and antinode is lambda by 4. Okay, distance between consecutive nodes or antinodes is lambda by 2, and distance between node to antinode but consecutive, this lambda by 4. Okay, so in standing waves, nodes and antinodes are formed, while in the sound waves, compressions and rarefactions are formed, and in transverse waves, crests and troughs are produced. Again, the nodes are the points where the amplitude of a wave becomes 0, and the antinode are the points where amplitude of a wave gets maximum. In one complete standing wave, how many nodes and how many antinodes are produced? So this is a complete wave. In a one complete wave, there is a node, there is also node, and this is also node. So in a complete one complete standing wave, there are 3 nodes and 2 antinodes. So in one complete standing wave, there are 3 nodes. 3 nodes. In one complete standing wave, there are 3 nodes and 2 nodes. 3 nodes and 2 antinodes. This is antinode, this is another antinode, while these are nodes. Then how much will be in 2 waves, 2 complete standing waves may, how many nodes and antinodes will be produced? Let us see. This is a one wave and other one is this. These are 2 waves. In these 2 waves, this is a node, this is another node, this is node, this is node, this is node. Node, node, node and node, this is node. There are 5 nodes and how many antinodes? This one, this, 4 antinodes and 5 nodes in 2 complete standing waves. There are 5 nodes and 4 antinodes. In one complete wave, there are 3 nodes and 2 antinodes, and there are 5 nodes and 4 antinodes. It means that number of antinodes will always be smaller than nodes by 1. So if we relate the node and antinode, number of antinodes will be equal to number of nodes number of nodes minus 1. So this will be the number of antinodes. number of nodes में से एक सब्ट्रैक्ट करेंगे तो हमें नंबर ऑफ एंटीनोड्स मिलेगा. जैसे यहाँ पे नंबर ऑफ नोड्स -1 अगर करेंगे तो एंटीनोड हमें मिलेगा. तो दीज आर द 3 नोड्स. -1 equals to 2 and is equal to antinode. So there are 2 antinodes in a one complete wave. And if we want to calculate from this, then there are nodes. -1 equals to antinode and the nodes are 5, then -1 equal to the 4. So there are 4 antinodes present in 2 complete standing waves. But in another way, we can also say -1 there is subtracting and at this point at this side this will be added. So number of nodes, let's say number of nodes, or we can write this, number of nodes is equal to number of antinodes plus 1. ठीक है। तो नंबर ऑफ नोड्स जो है वो हमेशा ज़्यादा होगा किससे, बाय दी एंटीनोड्स, कितना, बाय वन। ओके, सो दीज आर दी all about standing waves. Okay, thank you.